Okay, let's see if IBT can be applied here. So we're just going to check our conditions. And the very first condition is that f of x is continuous, and that is true. So that's right, f of x is continuous for all values of x greater than 0. Since we have the square root function in there, that's defined as long as x is greater than or equal to 0. 0. Okay, so our interval was 0 to 2, so that works out. So f of x is continuous on our interval. Nope, not number 2 yet. Okay, number 2, we got to show that the endpoints are on opposite sides of 0. So f of 0, our first endpoint, is equal to -1. If you plug in that 0, the function you get -1, and that's less than 0, which also happens to be less than f of 2, which is equal to, and I'm not going to type out the square root, but you can go to it here. So f of 2 is equal to the square root of 2 minus 1. And that's greater than 0 because the square root of 2 is bigger than 1. So root 2 minus 1, it's about 0.41 something or other. Doesn't really matter, it's just positive. So 0 is between my two y values of my endpoints. So the conditions are met for IBT. So IBT applies because our conditions are met. And there is a c value, there's a c on this interval such that f of c is 0. And then it asks us to find it. So if it says if yes, which we said yes, it does apply, explain why and find the 0. Well, we explained why, we checked our two conditions right here. And to find the 0, we just find out where's this function equal to 0. So 0 is equal to root x minus 1. And if you solve that, you get x equals 1, and you can see that 1 is on this interval here. Okay. And really, I guess if this is a little confusing, we're really finding, they call it c, so you plug a c in there. C is 1.